Welcome to Brain Vision.
Hello everyone, here it is given. Each gas A and B having the mass 2.4 kg and radius of gyration 60 millimeter, that is 0.06 meter, while gas C having the mass 12 kg and radius of gyration 150 mm, that is 0.15 meter. Radius of C is 200 millimeter, that is 0.2 meter, and that of A and B is same 80 millimeter, that is 0.08 meter. If couple M of constant magnitude of 10 Newton is applied to B, applied to gas B, calculate number of transition gases required, theta for of C required to increase velocity, angular velocity omega 1 100 rpm to 450 rpm, and B, tangential force on A. Let us see here. First of inertia of gas A and B, both having the same because both are of same dimension, m into k square. Mass is 2.4 kg. Radius of gyration of each is 0.06 meter. So it will be 8.64 into 10 to the power minus 3 kg meter square. Moment of inertia of gas C, mass is 12, radius of gyration is 0.15, so it would be 270 into 10 to the power minus 3 kg meter square. Here it will be Ra is equal to omega A is equal to Rv is equal to omega V is equal to Rc into omega C. This condition to be satisfied. So omega A is equal to omega V is equal to 200 by 80 into omega C, that is 2.5 omega C, and we can write angular displacement of A, theta A is equal to theta V is equal to 2.5 times of theta C. Now kinetic energy we will calculate by the formula T is equal to half I omega square. Here angular velocity of A is equal to that of B is 2.5 times of omega c, given omega c is equal to 100 rpm, that is 10 pi upon 3 radian per second. So angular A and B, you will get this is 1. So 1A is equal to 1B is equal to 2.5 times of omega 1C, that is 25 pi upon 3 radian per second. Initial energy of gas A, half moment of inertia. You have to use this relation. Moment of inertia we have calculated of each individual gas and angular velocity. So T1A will be 2.9609 joules. Energy of B will be the same because both having the same dimension. Still I am writing here. So both having the same initial kinetic energy. Now initial kinetic energy of gas C half, its moment of inertia is 270 and angular velocity is 10 pi by 3. So it would be 14.8044 joules. So total kinetic energy of the system, total initial kinetic energy of the system T1 is equal to T1A, T1B, and T1C. Substituting the value, so T1 we will get 20.726 joules. Now final final position, omega 2c is 450 rpm, that is 15 pi radian per second. So omega 2a is equal to omega 2b 2.5 times. So you will get 37.5 radian per second. Now you may calculate total energy half IA omega 2a square half IC, sorry, IB omega 2b square half IC. Substituting the value 8.64 10 to the power minus 3 into 37.5. I have written here wrongly, so I am correcting it. Same for B. Half IC 270 into 10 to the power minus 3 into 15 pi whole square. So total final kinetic energy of the system. This is total final kinetic energy of the system. Work done by couple from position initial to final m into theta. This is 10 into theta b. Applying the theorem, T1, sorry, T2 minus T1 of gas V. This is 10 into theta B. T2 I have calculated directly. I am substituting the value here. And T1 we know. So on solving it, theta B you will get 39.898 radian. Of Kersi, theta C will be theta V upon 2.5. So angular rotation of Kersi will be 15.959 radian. So one of the answer you will get 15.959 radian or divided by 2 pi. So it will be 2.54 revolution. Now applying work energy theorem for gas A. Rotation of gas A, if you see, then theta A is equal to theta B, that is 39.898 radians. So if we apply work energy theorem, for gas A, it will be work done by couple is equal to change in its, this value is M A into theta A half I 8.64 into 10 to the power minus 3 into omega square 37.5 pi square. This value already we know, T1A. This is for A, remember it. .9609. So from here you will get MA is equal to 59.957 minus upon theta A. Theta A is given 39 point, so it would be 1.4285 Newton into meter, and this will be tangential force into radius of A. So tangential force acting on the gas will be, radius is given 0.08 meter, 80 millimeter, that is 0.08, so it will be 17.86 Newton. That is the answer for this problem. Thanks for watching.